What's happening? Alright, Mr. Pagan here, and we're talking about angle classification. Now, a lot of this stuff we've already talked about when we're doing protractors and things of that nature, but let's formalize it and make sure we got it down before moving forward. Now, first, naming an angle. Remember, an angle is constructed of two rays that meet at a point. A ray going in this direction and this direction, and the point they meet at is called our vertex. In this sense, my vertex is point B. Alright, so then I'm going to call this point A and this point C. And I'm going to put a little number 1 here. Now, when we name this angle, we can name it multiple ways. We can name it angle ABC or angle CBA. Okay, again, our vertex has to be in the middle. Alright, and then you could also call this angle B or angle 1. And this angle is specific for that. It's special because it only has one angle at vertex B. And if there's a number there, you can always call it by this number. Now let's look at this example over here. I'm going to call this A, B, C, D. And I'm going to ask you a question. Can I call this angle A? The answer is no. Alright, the reason for this is there's multiple angles at vertex A. We have angle BAC. We could also call this angle CAB. And we have angle CAD right here, which we could also call DAC. So you can use this when there's only one angle at that vertex. However, if you have multiple angles at the vertex, not going to work. Alright, moving on. Types of angles. Okay. Again, we should know this stuff, but let's formalize it and make sure we're all on the same page. First thing we have is an acute angle. And an acute angle, the measures are greater than 0 but less than 90. So this x value inside of the angle has to be smaller than 90 but larger than 0. In a right angle, the angle always measures 90 degrees. And that's kind of how we justify an acute and an obtuse angle. Because if we draw a right angle, your acute angle is always going to be inside the right angle. And in an obtuse angle, it's always going to be outside of a 90, because in an obtuse angle, it is smaller than 180 but greater than 90. So the measure of its angle itself, measured in degrees, is greater than 90 degrees, however less than 180. Those are the restrictions for an obtuse angle, and an acute angle has restrictions of 0 and 90. Alright, and then lastly we have our straight angle, and a straight angle is always equal to 180 degrees. And one way I like to remember this is, let's say I start here and I go all the way around and make a full circle. That would be 360 degrees. So half of that, from here to here, would be 180 degrees. A straight line is always 180 degrees, and in geometry we can assume straight lines when we see them. That's a very important point. Okay, so let's look at this example down here. What are the possible range of values for x? So let's say this angle measures 2x minus 10. Let's call it angle A. And let's say angle A is acute. So the possible range of values for x. So if it's an acute angle, we know my restrictions. Okay? My restrictions are it has to be bigger than 0 than smaller than 90. Now, because we don't know if this angle measures 30 or 60 or 59.9999, 89.99999. We just know it's smaller than 90 and bigger than 0. So it could be 1, it could be 89, or anywhere in between. So we have to find all the possible values for x. So we know angle A is smaller than 90 but bigger than 0, and we know angle A equals 2x minus 10. So I'm just going to substitute that value in there. So we really have to do two problems. We have to set 2x minus 10 equal to 0 and 2x minus 10 equal to 90. So what we're going to do is find the two extreme values, and then we'll know everything in between is going to work as well. So to solve this equation, I'm going to add 10, divide by 2, and x is 5. All right. And then over here, I'm going to add 10, divide by 2, and x is 50. So we're going to say x has to be bigger than 5, but less than 50. Now, what does that mean? That means x has to equal any of the values in between there. So let's test one. Let's say x is 10. Now, is 10 between 5 and 50? Yeah. So let's see. Let's take our angle A. 2 times 10 minus 10 is 20 minus 10. I'm sorry. 2 times 10 minus 10 is 10 degrees. Would a 10-degree angle be acute? Yeah. Let's test one outside of it. Let's just use the x equals 4. Okay, because 4 is not in this range. 4 is over here. All right, so we would have 2 times 4 minus 10. Oops, excuse me. Minus 10. So that gives me 8 minus 10. So it would be negative 2 degrees. Is it possible to have a negative angle measure? Did this angle disappear and then come back in the negatives? No. Impossible, so that value won't work. So the possible range of values of x is anything greater than 5 or less than 50. So basically between 5 and 50. That's that there. And then I want to talk about congruent angles. Real quick. Let's just say we'll call this angle A and this angle W. All right. Now, if we knew these angles were congruent, so let's say they're both acute, we can see, let's say they both equal 16 degrees. All right. You can mark them congruent. So if I put the same amount of tick marks in both angles, that would express that they're congruent without ever saying anything else. If I just have those tick marks, we could say they're congruent and set them equal if we knew anything about them. So just a little point I wanted to point out. If you see that in worksheets or on your homework or in the text, that's what that's saying. They're just saying they're equal. All right, well, that's all I got for now. I'm out. See you later.